Well, hello and welcome to GatsbyCamp Fall 2021. Thank you, Kirsten, for the intro. That was awesome. Leonard, how you doing today?
I'm good, and you?
I'm good. I'm good, man. Let's get into this talk. So we're here to talk about parallel query running in Gatsby 4. What is it? Why is it? And how do I use it? Right? Oh, by the way, my name is Patrick, and I am the senior product manager for Gatsby Core Framework team, which was focused on the open source project.
And my name is Lennart Jörgens. I also work on the open source team, specifically on the framework. And you probably have seen me on the GitHub repository if you opened an issue or pull request in the last 2 or 3 years. So to get things started here, I prepared a demo, and it will show a speed comparison of Neural Lake's doc site. It's an open source site powered by MDX. You can also run locally if you want. And it really shows the benefit of parallel query running. So without further ado, let's start the video here. In the beginning, the race is like on equal levels, but soon enough you will see that the right side just speeds away and in the end will win this race by a long shot. So both have started now with the query running, and do you want to point out the obvious thing here, Patrick?
Yeah, so look at the very bottom line here. On the left-hand side, well, we'll say there's two sides of the story, right? On the left-hand side is the current version of query running in Gatsby 3. And the right-hand side is the parallel query running architecture running in Gatsby 4. And you can see the percentage differences right now in this video. If you look at the very bottom line, left-hand side I see 37% run page queries, and the right-hand side I see 93%. So somebody's winning this race pretty easily right now.
Yeah, it's not even a race, really. It's not fair. And like the second thing I want to point out is I also opened HTOP here to see the core utilization, and that's really where the big difference is. So on the left-hand side, only one core is used at a time, and on the right-hand side, all cores, in this case 8, are utilized. So um, that's really where you see the difference. So if I continue to let this run here, the right-hand side is finished before the left-hand side is even finished with the page query running. So yeah, let's see. Okay, now also the left-hand side is done. So that's 1,400 seconds versus 880. Huge win in speed. And with the following slides and explanations, we want to show you how we got there, go a little bit more in depth, and then in the end also explain how you can use it. Okay.
Yeah, so everyone knows this slide, this quote. Well, maybe not everyone, but this is a very, common thing that's used, right? It's really about, does your site help or hurt your conversions with your visitors? So if you have a slow site, people will bail on your site. That's the gist, right? There's a lot of metrics that kind of back this up over time. You can Google, page speed and conversions, but this is a huge driver to people exploring and utilizing static sites in their businesses. And that's why we at Gatsby and our customers all still believe static is best. So keep going. And actually, let's back up one slide. I haven't really told so why is static best, right? So maybe this is the first time you're looking at a Gatsby talk or you're kind of evaluating Gatsby, right? Well, when you have a static site, you get the fastest, most resilient, secure, scalable experience for your visitors. What that means is we're putting all of these assets out at the edge at the CDN. So there's no like server went down, sites down, or spike in traffic. Oh, my servers are overloaded. I'm going to have a huge bill. You just don't have that with a static site. It's all pushed at the edge, and it's incredibly fast. And so there's no latency. I mean, there's just the smallest latency you can ask for, and it's super resilient. So let's keep going. But in order to get there, in order to get to that outcome, there's something I like to refer to as the jam tax. There's this upfront build time that you spend putting everything together, making it super performant, pushing it out to the edge, pushing it out to your CDNs. And that's the trade-off. That's the very, consciously selected trade-off that folks make when they go to a static site or they use a Jamstack site. So we always think about, how can we, we understand that's a reality, but how can we keep moving this to be a world of less of a trade-off, maybe zero trade-off? So building all those assets in front, we know that's the price we pay, right, to get that great experience on the other end. But how can we keep driving that down? So we've looked at multiple ways of driving that down over time, driving that upfront cost down over time. And Lennart's going to take us through a lot of the details of that. But as we continue to kind of chip away at the portions of the build process that take the most time, the next thing to surface itself was the query running stage of the build process. So this is the query running stage of building your Gatsby site. And perhaps, Lennart's here. So Lennart, can you take us through again? What is query running? Why is it important?
Yep. So query running is really the heart of getting the data that you requested in your page in static queries. So let's say you source from Contentful and you have Markdown and so on and so on. Then really in this step, the data is all collected together to then in the end or after that generate the artifacts. And as you said, Patrick, we looked at the data, more specifically at our telemetry. And while we've seen in the past that image processing took quite a bit, and we parallelized that and we optimized that, now we saw, hey, we need to tackle query running here since it now takes a huge portion of that.
Oh, yeah, and I do want to add an additional thank you to all of you who opt into the telemetry that use Gatsby. This is how we use that telemetry. We use it to find what are the areas of pain that our users are experiencing, and then we put projects around it to drive those pain points down. So just huge thank you to opting into that telemetry. Thank you.
And to get a little bit more into the detail with query running, so inside Gatsby, we currently have this in-process local database. It's Redux under the hood, really. And when you have your page in static queries, we use those to interface through GraphQL to that local database. So we use your queries to run queries against that local database, and then we get the data out of it. The problem here, or not the problem, the opportunity here is that we have to process also a lot of things here, like Markdown or base64 previews for those fancy placeholder images. And those are or can be really CPU intensive. So when that's all done, we use the data to then build the artifacts that you get out of your Gatsby site and eventually upload to your site.
Right. So,
yeah.
Oh, sorry. Go ahead, man.
Yeah, and that's really where parallel query running comes in. Do you want to walk us through how we thought about that, really?
Yeah. So, Lennart mentioned a couple minutes ago how, we optimized around our image processing. We'll talk about that again a little bit. But there was a number of optimizations we made along the way. And we thought, well, query running is such an important and kind of expensive step of the build process. How can we re-architect? What's it going to take to drive the cost down there, right? And so we said, well, why don't we look into running all of that in parallel?
Yep.
And that may seem like just run it in parallel. But it can turn into kind of an iceberg initiative. And what I mean by that is you see parallel query running above the water, but below it, is all of the kind of thinking and work and re-architecture that was needed in order to enable this for all of the users of Gatsby. And so um, we went through quite a bit of evaluation, the core team did, to come up with the strategy to enable what we refer to as parallel query running. So let's talk about it.
Yeah, I think, funnily enough, I think this iceberg image is actually a meme that people like to do.
Yeah.
So, yeah, like here, this diagram seems rather easy. So it's easier said than done to parallelize things. But yeah, we push out the queries that you all have to all the available cores. Most machines, and especially now the serverless architecture, they have quite a bit cores to utilize. And when that's all done, this is really how it works under the hood. So, as Patrick said, we had to investigate an alternative to our in-process local database, really, to have something that we can use to share the data that a worker would need across different processes. And we landed on LMDB, more specifically on the node implementation called LMDB-store. And also a huge shout out to the maintainer of this, Chris. He's been really helpful in getting us up to speed and running with LMDB. And as you will also see in other talks, for example from Avi, this also unlocks other or different use cases. So in this diagram here, the main process shares information with the shared database, and the shared database shares back information. And really that information is in the end the build artifacts, because the workers are doing the query running that I just explained. So they take the data, they process it, they run your queries, and then they put out the artifacts that the site needs. And then in the end, the main process, puts together the pieces of the puzzle, and the end result is the same, only with the difference that it didn't run in a single process, but across multiple cores, across multiple machines possibly, and they all communicated together.
Yeah. And this is the path that the team took here has set us up for considering this solution in multiple problem sets, right? So we've introduced a persisted shared database through LMDB store for your Gatsby sites. Well, what are some other ways? What are some other uses? What are some other problems that a shared kind of persisted portable data store can help us solve and help solve for you? These are the things we're starting to explore next. So while we're delivering this right now, this has kind of spawned additional ideas and ways that we can solve some other long-standing problems. So be thinking about that and share your ideas back with us if something really kind of piques your interest.
Yeah, absolutely. So in total, or to explain this, in the end, you have faster builds with this. So we not only parallelized image processing now, but also query running. And I guess the faster builds could have an asterisk or a little grain of salt portion here, because what we really have seen in our testing is that especially sites with heavy queries, with CPU intensive transformations, really benefit from this.
Spend a lot of time. Yeah, those that spend the most time in query running.
So let's say if you only spend 10 seconds in query running, then you won't see that huge of a difference than which what you have seen in the demo we showed at the beginning. But for bigger sites or expensive queries, you will see that. We will also show some more diagrams in just a bit. But before that, Patrick will talk a little bit more about static scales.
Yeah, so it's critical that Gatsby is something that you can rely on and choose confidently and know that we're going to grow. We're going to allow you to grow to the size of project that you need. And so, kind of going back over time, let's talk about all the innovations, kind of in speed and scale that we've done at Gatsby. So Gatsby at the beginning, created as a static site generator. That's great. Fast sites. Problem there, a little change requires a rebuild. So then incremental builds were introduced. So that got you to a point where you could still have those great fast sites. They could get bigger. You could make small data changes and so on. You're not going to rebuild the whole site. Next thing that cropped up was parallel, the image processing was really expensive. It became the next big bottleneck to tackle because you want beautiful imagery on your site. Many of you do. And so in order to do that, it's incredibly CPU intensive. So that was parallelized. And now, after that was solved, we saw query running became the next big bottleneck to tackle. And so we tackled that by way of parallel query running, leveraging a kind of a core re-architecture of Gatsby around the way that it stores and shares data. But we're not stopping there. To really ensure that Gatsby scales to your needs and supports the dynamic scenarios that you really require for kind of maybe some larger commercial projects, we're introducing server-side rendering in Gatsby 4, as well as something that we refer to as deferred static generation. And hopefully that name's like super obvious what it is. It is static site generation. We're just deferring specific pages until first user request. Now, this is a little bit different from some other models you may have heard about in the sense that there's no stale hit, right? We're not serving a stale bit of content while we're getting the latest content. And we're leveraging the shared data store that you saw in the previous slides to speed up the retrieval of that new content. So we're effectively keeping things in sync for you under the covers while deferring the building of certain pages until the user first needs them. And again, Abhi gets into more of that in his talk. So make sure you check that out.
And here are some more slides with diagrams, because who doesn't like diagrams? So what do we see here, Patrick?
Yeah. So we love diagrams and we love slides. But in all seriousness, right? We wanted to show, not just tell you about this stuff. So here are the two build profiles of fairly representative sites that we see in the kind of the mid tier of Gatsby sites, right? So on the left-hand side, you see 28,000 page contentful site. On the right, you see a 9,000 page MDX site. Hint, hint, that right-hand side over there and 9,000 page MDX, that is the New Relic docs site that we referred to earlier that Lennart showed you in the video. So on the left-hand side, we're seeing about a 2.5 to 3x improvement between with parallel query running and without. And you can see kind of the development cycles on the left there too, right? Where, we're kind of figuring this out. They crossed the lines a little bit. Okay, now we've got this figured out, right? So we kept tuning and iterating on the way that we implement it with real sites. This isn't just a little lab where we have sites that are perfect, only have the minimal implementation of Gatsby. These are real legit sites. And on the right-hand side, the 9,000 page MDX one, the New Relic site. Oh, by the way, hi New Relic team, good to see you. It's a 3x improvement for them. So substantial stuff for real-world sites.
So at this point, you might ask yourself, well, how can I use it today? You really have two options. So if you can't just yet update to the Gatsby 4 preview, you can also use it in Gatsby 3 today. You can activate the parallel query running flag here inside your Gatsby config. And the Gatsby 4 preview, we activated it by default for you, so you don't have to set any flags there. And if you hit any bugs, have feedback, or any other things you want to comment about, please go to the link here. It will lead you to a public GitHub discussion about this feature, and we will monitor that and be happy to help you with anything. And I guess that's pretty much our talk here. I hope we could really bring home the value here that you will be getting out of this. And if you still have any questions, feel free to reach out on Twitter to us or go to our GitHub discussions there. And yeah, from my side, I hope you enjoyed it. And
well, I enjoyed it, Lennart.
Yeah.
I thought it was great.
And,
it was great.
And see you at the rest of GatsbyCamp.
Yep. Thank you for attending our talk, and definitely be straight shooter with us on the discussions there. We need all the feedback, the good and the bad. Make this better for everyone in the open source community. Thank you so much. Enjoy the rest of GatsbyCamp.
Bye-bye.